Typically, a payment of meeting fees may be required, as it is when you attend here. In .11, we have standards development based on individual participation. IEEE also has a corporate standards development process that can be followed, but that is not us. We are using an individual-based process. So people who participate are participating as individuals. And then the standards that we develop are also adopted typically internationally, and we use the ISO JTC1 SC6 group, ISO IEC JTC1 SC6 group. We forward our 802.11 standards to them. They typically run it through their process where there are votes by the various national bodies, and then the standards are adopted as international standards and given a similar but different title, 8802 versus 802.11. The standards development process flow is shown here. You see that on your left, my right, the first step is project approval process, or the which begins with an approval of a project authorization request. And this is analogous to a working group charter, if you will. There has to be something that describes when a project is started, what the scope is, what the intended deliverables are. And so we start there, then we develop a draft standard that's done in a working group. 802.11 is the working group. So there's a working group process, which is shown in the green box, that develop draft standards. Then there's a sponsor ballot phase, which is a phase of review of the standard where anyone in the world can participate. It's not just people who have been attending .11 meetings and participating in the 802.11 working group, but it's anyone who participates in the IEEE SA process and signs up, pays their, what is it now, $35 fee or so, and is a member of a sponsor ballot pool for this particular ballot. And then there's a standards board approval process. This is at the IEEE level. So all of the 802.11, 802.15, all the 802 standards, as well as the IEEE standards that are developed in different organizations, for example, power standards, all go through this IEEE standards board approval process. After that occurs, then a standard is published. So it also says typical project lifetime of 4 years. Some amendments or developments take a shorter period of time, others take longer, but the initial authorization is typically for 4 years, and you're expected to finish in 4 years or have a good reason why you should get an extension. This is a pictorial chart that I have to acknowledge came originally from Donald Eastlake's presentation, since Donald is here, that shows at the center wireless body area networks, wireless personal area networks, wireless local area networks, metropolitan area networks, and rural area networks, where the distances and the ranges change among all these various networks, but these are all within the 802 family. They're all developed within the 802 family. And the one that I'm going to be talking about is the wireless LAN, which is 802.11. Listed here, you see the various iterations, 802.11, A, B, and the letters you're familiar with, BGN, which is in 2.4, AN and AC, which is in 5 gigahertz, AH, which is addressed sub 1 gigahertz, and AD, which is addressed 60 gigahertz. So within .11, and we'll focus more on that now, our scope is wireless LAN. So the range is typically can be 100 meters, can be less, can be more, depending on the particular application. If you're designing a very high density deployment, for example, in a stadium or in a conference room or in a university conference hall, your range for each access point will be much less. than 100 meters, where in a wide open space it may be that long. Typically we use unlicensed spectrum, and this is important, it'll come up later. There are some very important attributes of unlicensed spectrum. First of all, it's available for anyone to use, and it must be shared, and shared in a fair manner. There are a couple of exceptions, 802.11y, which hasn't really been developed, but it was developed for the lightly licensed 3650 to 3700 band in the US, and 11AF for TV white space, where there are additional rules about using that spectrum. 802.11 and Wi-Fi, the figure here shows our origins. Back in the 90s, the idea for .11 and the idea of connecting devices locally, wirelessly, originally came out of NCR. Perhaps you don't recognize the company NCR back in the day, National Cash Register Corporation. They sold, teller cash machines. You know, you'd go to a retail establishment and that's the machine they would ring your purchase up on. And so from a retail point of view, it would be beneficial to be able to connect devices or move equipment around without having to move all the wires. And so that's where the initial research first began, and we've come a long way, obviously, since then. And speaking of coming a long way since then, the example here is one of 802.11 technology being used in a very, very dense deployment at a major, well-known sporting event held every year in February. This last one was held in Santa Clara in the US. I won't say the exact words, you get to guess which event it was. But basically 10 terabytes of data during the duration of the game, all carried over Wi-Fi. So it's pretty phenomenal. And so this is really where kind of pushing the bounds of all the applications that could possibly be used for wireless and wireless LAN. And the system designed here in the Santa Clara Stadium, Levi Stadium, basically handled that level of traffic. One more example of the deployment and the broad use of Wi-Fi and 802.11 technology. This is a slide taken, the reference is down here, you can look it up. Presentation at the March IEEE 802.11 meeting by Andy Gallants, who's a UK regulator. The regulators basically decide how much spectrum and what rules apply to the spectrum that we get to access. And so this is an example of UK data in 2014, and the basically Ofcom calculations of the amount of traffic carried on Wi-Fi networks and on cellular networks. And so this is the kind of information that regulators are tracking to see really what the needs of consumers at all levels in their countries are. Question, are the two columns different years? It's per month, so I think it's a couple of months. Okay, but basically speaking to the ubiquity of deployment of Wi-Fi. The next slide is provides a link for you to the Wi-Fi Alliance, which is the marketing organization that advocates for Wi-Fi technologies and provides interoperability certification for Wi-Fi devices, so that devices from different manufacturers can interoperate seamlessly between each other and ensure that. As well as a pointer to a graphic that was put together showing the growth and of the deployment and of the technology over the years. So now we'll look at 802.11 status. And someone was commenting earlier about the size of this document. It is a little overwhelming. Right now, the size of the 802.11 2012 document is over 2,000 pages, and it will be larger when we come out with the 2016, hopefully, edition. But basically, you can see the history from 97, starting with the basic 1 and 2 megabit standards, coming to the 2003 roll-up, which added 11A and 11B, and basically, as well as the 11D. Then 2007, which added QoS and security, most notably 11J for the Japanese bands, and 11G for 24 megabits per second in the 2.4 band. So looking back into 2007, it was very, looking back on it, it seemed complex at the time, but now looking back on it, it seems pretty simple. Because coming into 2012, we added, you count here, 10 additional amendments to the draft, notably 11K radio research measurement, 11U interworking between external networks, 11Z TDLS, which is a tunneled direct link protocol, fast roaming, 11R, and you can read the others along the side there. But notably, this is when 11N rolled in, and 11N was published in the 2010 timeframe and provided a significant increase in the throughput in both 2.4 and 5 gigahertz, with the introduction of wider channel bandwidths as well as MIMO technologies. And now we're working on the 802.11/2016 revision of the standard, which will roll in the amendments that are shown here, as well as incorporate a number of small features and corrections. And so right now that document is in the final stages, we hope, of just going back up sponsor ballot. So the work on that document has completed in the working group, and we're now in the first recirculation of the sponsor ballot. So hopefully that will finish and be approved in 2016. So the types of groups, and so this is a definition of nomenclature really, and if you're familiar with the IETF rules, when we look at these different groups, how do they correspond? So .11 is a working group. In the 802 universe, 802.11 is a working group. 802.15, which Charlie will describe as a working group. 802.18.19, those are all working groups. So it's somewhat analogous, each of those is somewhat analogous to an IETF area. Then within the working group, and this is for .11 in particular, we have standing committees, task groups, study groups, and one topic interest group. And these are roughly analogous to an IETF working group, which would be a standing committee looking at a specific subject, really, within the area. A task group is similar, focusing in on a subject within that area. And then study groups and topic interest groups are like BOFs. They exist for a short time. They determine whether there's sufficient interest in a topic to go ahead and create a more long-lasting effort and set of deliverables around that topic. I'd also like to point out RFC 7241, the IEEE 802 and IETF relationship, which describes the correspondence along with more detail of the processes of the two organizations, especially even if you're just getting started in the IETF. I think it's an interesting document to look at. This was written a couple of years ago, updated from a previous document, but the intent being to provide a resource for participants from each organization to better understand the other. This slide, and I'm now on slide 15, is a list of the current active groups, subgroups within 802.11. So you see that we have a number of standing committees related to architecture, power review, regulatory, and wireless next generation. Wireless next generation is where we have presentations on general topics of interest or topics that people might want to consider starting a study group on. Power review has to do with project authorization request review. Any new project or new working group or task group has to go through a process within the whole IEEE hierarchy for approval. And part of that is the definition of a PAR, or a project authorization request. And so within .11, we review the proposed PARs of all the other 802 groups. So that's what that particular standing committee does. The 802 SC is the standing committee at the 802 level that we track and manage administratively in .11. And this is the group that follows the activities within ISO IEC JG1 SC6 and sees to see if there are any items there that we need to respond to or comment on, as well as that's where the documents are submitted for international standardization. And then the task groups you see listed, and we'll go through, I have a slide on each of these, and so we'll go through in each of these in more detail. Okay, here is a slide that shows among the active task groups here that you just saw a list of, where are they along the timeline continuum of development? So if I had a pointer, I'd walk over there or point to the TIG and study groups, right? Those are in the earliest development phases. So those are like BOFs on the left. Then we have task groups without an approved draft. So these are activities where an amendment is under development, work is being done, for example, defining use cases, requirements, functional requirements, simulation work being done, but they haven't produced a draft yet, a first draft that's been approved. So they're yet earlier in the development time frame. Then we have three groups that are in working group letter ballot. So they have a draft, and it is either a draft 1, draft 2, draft 3, but they have a draft. It's been approved, and they're continuing to refine it. So they are, just going back here, they're in the second green box that says develop draft standard in working group. Then we have a sponsor ballot phase, and we have three groups there, TGMC, TGAI, and TGAH, which are nearing completion. And then TGMC, you see the arrow that points to the published amendments that are being rolled in to produce the one large document. And then we're targeting that the published amendment will come out in 2016, but it's not out there yet, just to make that clear. All right, so before we go through the projects under development, just at a high level, what are the forces that are driving innovation and driving the development of the amendments that are currently, people are spending time and a lot of energy developing? And at a high level, they're listed here. There's a continuing demand for additional throughput and more capacity in the wireless links. And that's what's driving AX and AY. AY is 60 gigahertz, as you'll see. AX is in 2.4 and 5. New usage models and new features. So dense deployments also driving AX. There's a demand for indoor location and better granularity of indoor location for a lot of different applications. And that's what's really behind TGAZ. Then technical capability. We have new technology. People are working on enhancements for coding, for modulation, for techniques to get more and more bits per hertz out of the radio. And so as those techniques become available and become more widespread, we want to roll those into the technology. And then finally, changes to regulation. I mentioned at the beginning that .11 uses unlicensed spectrum. That's important. And so when the regulations change, we need to respond to that. So the projects under development. First is TGAH. We'll go in alphabetical order. This is the sub 1 gigahertz amendment. So there are a number of unlicensed spectrum bands that are below 1 gigahertz. So if you think of your spectrum map, so 2.4 gigahertz is the lowest frequency that most Wi-Fi devices operate today. But there is more additional unlicensed spectrum below that at lower frequencies, where at lower frequencies you get longer range. That's the big draw here. And so there's work underway. You see the bands listed here, and at the end of the deck there's more information about the European bands. But the goal is to provide an amendment or a standard that will operate in those available unlicensed bands. And a lot of the applications that are being looked at are listed here. Extended range wireless LAN. So for example, if you have a large house, you may not get complete coverage with 1 or 2 access points. That with an additional access point or with the same access point with the addition of AH, you'd be able to get longer range for example, the recesses of your home where the hot water heater is Wi-Fi enabled. And you see the other applications here. I mean, people can really go crazy thinking about applications. The link is provided here to use cases and functional requirements. If you look through the use cases, they're really pretty extensive. Everything from farm applications, agricultural applications, industrial applications, just really tremendous variety. So the technology that's been introduced here, basically extensions to the OFDM5, which is a characteristic of 2.4 and 5. The technologies that are currently there, transmission range of up to 1 kilometer, which is, you know, again, significantly longer than you would typically get with a 2.4 system. Although it is seen in 2.4 systems depending on the antennas that are in use. TGAI is an amendment for fast initial authentication. And here there is some overlap, if you will, or some reuse of work that has been done in the IETF. With the, under technology, you see listed EAP, RP, or ERP in RC 5296. I don't know that that technology it was originally developed for 3GPP, but was not picked up in 3GPP. But basically, it's been incorporated as one of the possible techniques for fast authentication here, in addition to other mechanisms. So the goal here is to serve dense deployments where you have a lot of people hitting the access point all at once, and to make that initial authentication very fast and seamless. The other piece that's incorporated here is some techniques were added for making scanning more efficient. If you look at a lot of the traffic that goes over WLAN networks today, there's a lot of overhead traffic, a lot of probing. So the stations are scanning. Stations are scanning all the time, periodically, and that traffic fills the air. And so there are a number of techniques in this amendment to try and make that scanning more efficient. So there's less use of overhead traffic and more available for data traffic. TGI, this is a picture, technical highlights. So 11I, basically 11I was the original security amendment in .11 that introduced the use of EAP. And so the steps that need to be followed when you're using a 11i connection and you're using EAP, for example, there's the 802.11 authentication, which is just a 2-frame exchange back and forth. Then the association, which is again a 2-frame exchange back and forth. And then an EAP exchange, followed by the 4-way handshake that's indicated EAP key. And then you can get on with business doing DHCP and everything else that you really want to do. So the changes in 11AI are to provide different mechanisms to basically speed up that interaction. To either do the ERP mechanism where you establish keys ahead of time and then can do this very quickly, or there's the public key, a public key mechanism that's additionally defined. Okay, 11AJ is a China millimeter wave. Millimeter wave, these are the very high frequencies, 45 gigahertz, 60 gigahertz. And this amendment is building on the work that was done in 11AD. 11AD was the amendment that provided 60 gigahertz operation. You're just seeing now 60 gigahertz devices to come on the market. If you do a search on 60 gigahertz or 11AD products, you'll see some, for example, some Dell devices with wireless peripherals. And the Wi-Fi certification of 11AD is anticipated to launch in 2016. So those devices are just starting to ramp up. So this work in AJ basically is leveraging or building on the AD work, but for the China bands. China allocation of 60 gigahertz is much smaller than in the rest of the world. And so you can only get 1 or 2 channels of 11AD in China today. So this amendment will define narrower bandwidths of channels so that you can have more channels in which to be able to use. And they're doing that at 60 gig as well as defining a 45 gig operation. TGA-K, enhancements for transit links within bridge networks. This is not a PHY amendment, okay? This is a MAC amendment primarily. The expert on this amendment is sitting in this room. It's Donald Eastlake. Donald? Okay. If you have questions, please see Donald. But the intent of this amendment is to add additional bridging and transport mechanisms so that any stay device can basically be positioned in the middle of the network and have traffic transit through it in a more convenient and standard way, rather than it being, there are proprietary ways to do this today, but this would be a standard mechanism. TGAQ, this is in the early stages. They have a draft 1 that's under development, and this is called pre-association discovery. The goal here is to provide a discovery mechanism over .11 where services would be advertised and known to stations pre-association. So there are a lot of discovery mechanisms out there, right? Tons of discovery mechanisms. Most of them are, once you're connected, you start to get traffic and you can decode traffic. The goal here is to provide guidance to a station or information to a station pre-association of what services are available. And the next slide here gives a little bit more of the highlights that basically there's a container MAC protocol defined that will carry upper layer service discovery protocol and information. Okay, then TGA-AX. TGA-AX is currently I would say the largest project in terms of amendments under development. And the goal of AX is to provide a significant efficiency improvement in the radio link performance, particularly for dense applications. You can see here that the goal is to get a 4 times increase, at least a 4 times improvement in the per station throughput compared to what's currently being deployed in 11 and in 11AC. And this technology is most likely to be deployed in, like I said, very dense deployments where you have these extremely high bandwidth requirements. So the technology here, you see listed here, I'm going to describe 2 of the new mechanisms that are being added. The first is called BSS coloring. And BSS coloring was developed to give another degree of freedom or another parameter to enable an access point to distinguish, or a station to distinguish the traffic of others. So today, the primary means you have is which channel are you on? Are you on channel, in 2.4, right? Are you in channel 1, channel 2, channel 3, channel 4, up to 11, typically. In 11, in 5 gigahertz, maybe you're on channel 36. And then depending on what the deployment plan is and how the channels are laid out in a given area, you will see, for example, the arrows here show BSS 4 or channel 4, if you will. And so you will hear the radio, not you personally, but the radio will hear the traffic from another BSS on in the same channel, and defer based on the signal level because of it. So adding the concept of coloring, and this is so more information is exchanged in the protocol, in the PHY protocol, to give some indication of, well, I'm channel 4, but I'm blue channel 4, right? I'm green channel 4. So the blue channel 4s will just hear themselves. They won't hear they'll be able to distinguish the green channel 4s. And so this will give additional control or the ability to detect and respond properly, more efficiently to channel reuse. The second technical, there are many technical capabilities being introduced in AX. The second that I'm going to talk about here before my next 10 minutes are up is this technique, OFDMA, which is a means to further segment the channels and the number of users within a channel, so that you can pack more users into a particular a channel, and time slots and space slots within that channel, so that you can more efficiently handle small data frame packets. A lot of times the traffic that we see is there are some very, very long packets, but there's a lot of short packet traffic out there. And so this is a way to, if you have a client that just has a lot of short bursty traffic, you can allocate that client a smaller amount of the overall bandwidth. Okay, AY, we talked about earlier in reference a little bit with AJ. So the topic is 60 gigahertz, 11AD is out there now. Products will be coming onto the market in more volume shortly. 11AJ, extended that to customize it really for the China bands. 11AY is looking at extending 11AD with additional techniques. So no new spectrum, just very analogous to 11G, 11N, right? Or AC, 11N, to further get additional capacity in the 60 gigahertz bands. And you can see the applications here, primarily very, very short range. So wireless docking, wireless display, ultra short range communications. And here, for example, they're looking at one application of data center inter-rack connectivity, where the connections are really extremely short, but they're very, very high bandwidth. And this is in early days as far as status. They're pre-D 1.0, so on that timeline, they're before the first draft. Also early days is TGAZ, which is looking at enhancements to positioning or location determination. It's called next generation positioning. So in .11 today, we have a couple of features and capabilities that are used for location determination and positioning. One, there are basic RSSI measurements that client devices and access points can make and determine roughly what their location is relative to other devices. TGMC added fine timing measurement, which extends the timing measurement capability that was there in 2012 to allow further granularity and additional protocol frames that can be exchanged between clients to get so a client device, for example, could exchange frames with multiple access points, and then based on the information and the time difference of arrival of the various frames, determine its position. So TGAZ is going to extend that. Again, early days, they're pre-D 1.0. Okay, so briefly then, so those are the task groups. The task groups are the groups that will develop additional pages for that 2,000 or 3,000 page document, right? So those are the ones putting butter on the bread, if you will. The Architecture Standing Committee is again, a standing committee. It's resides permanently, but this group looks at the architectural models that we use, how those get extended for various applications, such as the General Link 11AK mechanisms, such as mesh, and make sure that we still have a coherent whole. They also look at how does the .11 architecture fit into 802 and 802.1 architecture. Because in the 802 family, right, the goal is that all of the 802 groups follow the same basic architectural model. And so when there are .1 documents to update or review, this is the group that takes the lead on that. As well as they look at defining MIB and management conventions. And here in .11, we are aware of the work that's underway as far as management and management extensions goes, but we haven't done anything yet in that regard. The basic architectural overview, where there's a single MAC and all the different PHYs that run on top of that. This picture is changing with AX because the MAC will be extended, so there really will be, I don't know if I'd say totally multiple MACs, but there will be significant extensions. And then regulatory standing committee in 802.18. So there is today a joint .11.15 regulatory group where typically the concerns and interests of both .11 and .15 are aligned from a regulatory point of view. We overlap in a number of the major spectrum allocations, although .15 has looked at a number of additional areas. So we work jointly there. Some of that work is transitioning to the upper level, basically, to the 802.18 technical advisory group. And this group is the one that interacts with and responds to regulatory items. For example, if there's a FCC, a US FCC NPRM, notice of proposed rulemaking that we need to voice an opinion on, that this group is where, and .18 are where those documents would be drafted. Likewise for ETSI in the EU and other regulatory bodies. And this work is becoming more and more important, particularly in the EU with new EU mandates. And there's a lot of work going on now in ETSI related to 5 gigahertz operation that a number of us are following. 802.19 relates to coexistence and related liaison activities. So coming back to where we live in the .11 world, right? We live in an unlicensed world. And so we really, really care about coexistence in that world. There's a lot of work going on now related to what's called LAA, or License Assisted Access coexistence. So in the 3GPP, among the 3GPP communities and associated participants thereof, there are a number of activities related to leveraging unlicensed spectrum, and particularly the 5 gigahertz band, into carrier networks and how to do that. Whether to use Wi-Fi technologies and just bring those in to a cellular network infrastructure, or to develop a new LTE waveform in the unlicensed band, and for carriers to use those technologies, basically an LTE technology in the 5 gig band. And there's significant work going on there in 3GPP. Liaisons are being exchanged, and discussions are underway among the two groups to make sure that the techniques and the protocols that are developed in 3GPP, which does not have a history of developing for the unlicensed band, right? That the protocols that they develop and the techniques that and the requirements that they establish really will enable fair sharing, because it's a totally different design model when you're working in spectrum you own and control, and you're the only one there, right? So it's like a centralized command and control system versus a distributed system, which is what we have in unlicensed. And which is one of the reasons why, we can deploy the folks in the NOC can deploy the wireless LAN network here and not be beholden to a carrier to do that, right? And that's something that we want to make sure is maintained. Okay, a little bit about the LRLP TIG. You can look at that. This is a long-range low-power topic interest group. I think I'm approaching the last 2 minutes that I have allocated. Areas of mutual interest. So there are links here to a couple of items. I'll highlight like 2 or 3 of them. One is the top link, Joint Meetings Agenda and Presentations. This is a link to the IEEE802 and ISG-IAB interactions and meetings and all the meeting notes and all of the groups and topics that are being tracked between the 2 organizations. So the goal is that the 2 organizations really work well and leverage the expertise of each group when areas of mutual interest come up. I did mention the 7241 document. 802 maintains a list of their liaisons, just as IETF does. You can find that there. And at the 802 EC level, there's a standing committee that Pat Thaler chairs. Pat, people have questions. So Pat coordinates at the 802 level so that we have at the 802 level a view of all the interactions going on with the IETF so that can be efficient and shared. As far as topics, multicast is the current hot topic, I would say, from a .11 point of view in the interaction with IETF. There was a presentation given at the November IETF meeting. The link is here. There were a number of further actions identified based on that presentation. One was establishing a mailing list for people who are interested in the topic. That is the link for that is here if you're interested in that and want to join. There's an internet draft that's been developed. Charlie is one of the authors here, and so there will be work continuing to go on that document, and the links are provided here. Additional information on multicast. Topics of mutual interest. So this gives you a little bit of history of what we have discussed in the past. So topics from QoS and DSCP code mapping. This remains an area of interest just because, you know, having the same values end to end is important. There was work done in the PAWS group to develop a protocol to access white space databases, and this relates to the 11AF amendment that was developed. Then CAPWAP protocol extensions, radius extensions, additional EAT methods, EAT method requirements. Also, we use the INA registry for a number of items. For example, defining domain parameter sets and basically try and leverage items that are there. Okay, and then I have some references. When I said that this document is available, publicly available on the Mentor website, that second link, if you go there, all of the .11 documents are public. You don't have to, I think they're available for downloading. You can get them there. And then the last 3 slides provide additional information on the AH spectrum. So with that, thank you very much for your time. I'll give the microphone now over to Charlie, who will give you the overview on 802.15 and .1 and .24. And then after that, we'll have time for questions on any of the presentations.
Great, thank you. Speak out this one too. So hello, I'm Charles Perkins, and I'm here to present some information about 802.15 and some things in 802.1 as well. I will just say a couple of things about 24 at the end. Before I get started, just mention a couple of things. As Dorothy mentioned, all the IEEE documents are available, publicly available, and this one has been submitted with this document number here, so you can get that if you want. This presentation I'm making is almost identical to that, but the thing is, I just happened to notice a couple of slight mistakes today, so I made a little change, but I will update this document with those very minor changes. And I want to make sure that if you have questions that you think of later, please don't hesitate to send me email. And the other thing I want to mention right away at the beginning is that Bob Hiley is here, and he didn't ask me, but if he would stand up so people can see you, he is, believe me, he knows a lot about 802.15 because he's the chair. And Pat Kinney is also virtually here on Meetup. I don't know, Pat, if you want to say something, but these guys are willing to also answer questions. I'm pretty much the new kid on the block on 802.15. I've only been doing it for 2.5 years or so. But when they asked me if I wanted to make a tutorial presentation, I said, heck yeah, so here we go. I'd like to make the same disclaimer that Dorothy mentioned, that we're both here to talk about the standards and give you our perhaps informed opinions on how things are and what's going on. But this is not to be considered a formal presentation from IEEE. So I have materials from Bob Hiley and Pat Kinney that I will discuss. It's an introduction to 802.15 and a little bit about how it came about. The task groups and interest groups and study groups. Thank you, Dorothy, for describing how those are analogous to IETF groups. And also there's I'll say a bit more about this new effort called 802.15.LLC. LLC stands for Logical Link Control, but we decided it really needed to be called ULI, but it never got to be 802.15.ULI, so that's just procedurally how it is. Here's a thumbnail picture of how these things fit together from the standpoint of IEEE Standards Association. And so here we are, 802.15, sort of right next to 802.11. But the 802.16 was famous for WiMAX, and then we have the coexistence group that Dorothy discussed. Yeah. Oh, I can. I will too, and thank you for asking. You know, there's something else I have to do, isn't there? Slideshow from current slide. I am not pretending to be a PowerPoint expert, but at least I know that much. Okay, so here we go. And there's 802.21, which should be considered relevant to wireless, but I don't have any material about that. If you're interested in that, I know I was involved with that group for a while. And then 802.24 is down here. 802.1, I will say a little bit more about later. So the initial purpose for 802.15 was about personal area networks, or PAN. And this has been going on now for 15 years. So it's, pardon? 17 years, when I was just a lad. But anyway, so it has quite many different kinds of activities, a wide range of data rates, and many different ranges of signaling, and a lot of range in the frequencies as well. So most of the applications in the market has been non-TCP/IP, but I'm quite sure that's changing. And also, as of a few months ago, they were shipping over 1 million devices a day. So I think it's fair to say that 802.15 really has a dominant role in Internet of Things. And if you 802.11 has a dominant role carrying mobile data, and 802.15 has a dominant role for Internet of Things. This is makes it, I think, very important for IETF. And by the way, I just want to mention that I am really happy to see the room is full, and there's a lot of very knowledgeable wireless people out there. So thank you for coming. 802.15 is distinguished in a particular way that it is only 802 wireless group that has multiple MAC protocols, which has the positives and negatives. So there's quite many projects that have been completed. I won't spend too much time on, but I at least want to mention .1 was the original Bluetooth, and standards were done in 2002, 2005. Then there was a coexistence document that was done for coexistence related to 2.11. So that group is in hibernation, and I'm not sure what it would take to bring it out. High rate in this context for .3 was 55 megabit per second, and that's also in hibernation, but there have been some amendments, and there's this 15.3c for high rate above gigabit per second. 15.4, I think, at least from my understanding, is where most of the interest is lately, and so I have a lot more to say about that. It's a standard for, it's written as a standard for low rate wireless networks, but the data rates are increasing. It's supposed to be extremely low complexity. Now what this means is basically that they didn't specify how to do everything. And so you have a lot of, I might say, vendor choice in how to implement functions like sometimes fragmentation or multicast or whatever it might be. There's also location-based services being specified for that. And most recently, there's a 802.15.4 standard with revisions issued with the 2015 date. And Pat Kinney wants me to reassure you that if you're going to do 802.15.4, you really need to look at that document, because some of the previous ones have errors in them that are kind of hard to figure out. So there's a lot of amendments to 15.4. So there's, and I have to say, I'm not familiar with a lot of details on these, but I mentioned them for completeness. So we have the ultra wideband, high data rate, and then a couple of PHYs for China and Japan. I'm not familiar with a lot of it, I'm sorry to say, so I won't be able to answer these questions, but if you send me an email with particular questions, I promise I will get you answers. So let's see, b.hiley@IEEE.org, that'll work. Okay, then we had 4F for RFID. Just for 4G, there's something called a field area smart utility network. And I think this area is going to have a resurgence, because at the recent IEEE meeting in Atlanta, they had utility companies coming in, and they really want to do this because I guess what happened was that they rolled out their equipment a few years ago, and now their equipment needs to be updated, but it's not always easy to find the vendors from 5 years, 10 years ago. So then in 15.4, there's a roll-up for the first A, C, and D. There's some kind of rules in IEEE about after you have a certain number of amendments, you're supposed to include them back into the base standard, and that can be quite a bit of work. 4K is for low energy critical infrastructure monitoring. I think that boils down to being emergency conditions and so on. And we have for TV white spaces, and 54N for Chinese medical applications, and also 4P for rail communications and so on. So there's this 15.4-2015 that I mentioned earlier has bug fixes, and you can see quite many, 7 different amendments. So you might say it was late. It should have been rolled up earlier, but that's the way it is. We also have some other completed projects not under .4 is mesh networking, which I'm not familiar with. .6 body area networking, and this one has been, I think this is undergoing some renewed attention with the standardization with ITU. Visible light communications, this I think is also known as Li-Fi, and it's actually undergoing a revised specification now, and there's a lot of interest in that. .3 has some more amendments that are under active. There's this 100 gigabit per second file layer for point-to-point, but it has very short range, and so their status is that they are reviewing proposals. I have not attended that group. There's another high-rate group, 100 gigabit per second with close proximity. And this, I think, is targeted for, you go to the airport, you stick your device down there, and a few seconds later, you get a nice movie. So, revision A, let's see. Oh, right. So there was something about 15.15 had 64-bit addresses. Now it is enabling 48-bit MAC addressing as well. More about 15.4. We have 15.4R for location-based services. This group is not, I did go to one of their meetings, but they're basically on hold. So I don't think anything's coming out of there very soon. Spectrum resource utilization, just to make better use of the available resource. And now we have a new group just approved a few months ago, 15.4T for higher rate PHY. Here the idea is that they would like to have something pretty much backwards compatible to original 250 kilobit per second data rate 15.4. But now that processors are faster and lower power, it's thought that we can do the same sort of thing with backwards compatibility, but 10 times the speed. So this is basically they're looking for proposals, and all the proposals I've seen emphasize simplicity. The last two active projects are really, you might say, bookkeeping. As time goes on, governments change their regulations about what spectrum can be used. And so we had .4U sort of a near-term need for arranging or updating the PHY for India. And then after that, there was quite many other regional subbands that need to be updated. Here you can see it shows in Europe and Mexico, and Brazil, and Australia, New Zealand. So those were not rolled up into the 15.4-2015 spec, so they'll have to wait for the next roll-up, but it's important to get these documents standardized. So this actually was approved the fastest I've ever heard of within 802 Wireless. They really went to town on that and got the project and other documents done very quickly. Again, about the visible light communications, 15.7a, I think they're essentially looking for new proposals for this Li-Fi. But there's another very interesting aspect to it, which is that everybody has cameras, and those cameras can be also used to transmit data directly from the camera. When they're collecting light, of course, and that could be modulated and data recovered from that signal. So I think that's called OCC. I have not intended this group, but I think it has its possibility to have extremely high rate and extremely low cost communications. There's another 15.A is for peer-aware communications. I think this is also very intended to be very high power but low range devices. And I don't have much more information about that, but they are pretty much getting ready to approve the draft. I mean, I guess I shouldn't say it that way. The way it goes is people get to a point in the working group, which you might call, it's like last call in IETF. Everybody in the group thinks that this is ready to be wide, get wider comment. So then they put out a document for comment to the wider IEEE wireless groups. And sometimes you can come back with 2,000 comments or more, and this happens in .11 as well. So what happens after that is you just have to assign teams to resolve these comments, and it goes, and they can go 12 hours a day or many hours going from one comment to the next until almost everything is ready to go for the next iteration. And so I think it's often that there's 3 or 4 iterations for the working group to resolve comments and more like local people that are involved with the working group. And then they open it up for what's called sponsor ballot. And I believe the sponsor is considered to be IEEE standards, if I can say it that way. And then anybody that is a member of IEEE standards can make comments on the draft. And that also produces quite many comments. So anyway, they're almost ready for the first step of the balloting. I wish I had more to say about 15.9. I think it's a really important effort. Is Bob Moskowitz here by any chance? He was chair of 15.9. That's ridiculous, terrible. Well, okay, that should say 15.9, recommended practice for a 15.4 key management protocol. Now, this is not actually the key management protocol. This is what tells you ways to actually transport the key management protocol signaling between the parties that are involved. And along the way, they had to do some other things. In particular, I can remember that they had to clarify the way fragmentation was done. So this has been now balloted on several times. They've resolved all the comments, and it's done. So they're now just awaiting publication. 802.15.10 is layer 2 routing. And this is a group I've been involved with a lot. So I can answer a lot of questions about this, but basically the idea is that they want to have layer 2 routing mesh under for 15.4. And it's supposed to handle all the MAC and PHY layers, and so and including TV white space. And 802.15.4 has essentially a personal area network has a coordinator called the PAN coordinator, and you can have multiple PANs hooked together by coordination with the PAN coordinators. There's also some other features about the short addressing and peer-to-peer routing that are taken care of in this layer 2 routing 802.15.10. So we've now been through 3 letter ballots, and we have still some comments remaining, but most of the issues have really been resolved. So we're expecting to nail down all the last resolutions for the comments and try to go for the next big step, which is sponsor ballot, hopefully in the early summer. So now I get to 802.15.12, which is this group I mentioned before for the upper layer interface. And I'd like to spend a little bit more time on this one. So as I mentioned, a lot of 802.15 has been deployed for networks that are not IP networks. But lately, with in IETF, there's 6TISH and 6LOW, and the role working groups, they are making use of 802.15.4. And it was noticed, first of all, that there were bugs in the spec. So then I mentioned before, the 802.15 roll-up fixed a lot of those things, so that's available now. But aside from that, the initial design philosophy was that 802.15 should be minimal. In other words, not really provide specification for everything you might need in a system using 802.15. So the result of that has been that there's been a lot of incompatible developments, and some of the deployments are not interoperable. So the thought with 802.15, and it should be approved relatively soon, and when it is, what does that mean? It is me. I'm going to ignore that. I hate when that happens. I should have turned it off already. So the idea is that we want to use essentially 802.11 has obviously been deployed for a lot of IP-based networks, and 802.15 has been not at all so many IP-based networks. So we're looking sort of at the .11 as a model for how to improve the deployability of 802.15 with IP-based networks, and specifically with 6TiSH, since the 6TiSH is using the time scheduling MAC facility for 802.15.4. So the point of having this upper layer interface is to find out what people really need to enable, let's say, more IP-based deployment, and specifically also with Internet of Things. So hopefully this effort will make it easier to provide portable and easier to implement applications. And I'll show a little bit more about that in just a moment. But this should allow a lot of new applications, but still have backward compatibility. In addition to the sort of this basic need for making 802.15 regular across all this MAC and file layers, we also want to make it easy to use layer 2 routing and KMP and 6TiSH, and have offer the facilities to 6TiSH and 6LoWPAN. So we're looking to those groups in IETF essentially as customers, and they're well aware of this work. So we also sort of in general need to have tight coordination with 802.1. It was mentioned earlier that Pat Taylor is chairing this IEEE IETF coordination committee. Well, I want to emphasize that I think that's a very, very good effort, and I think Dan Romascano is here also, or he was. He's also on this coordination committee. So if you have concerns or issues that you'd like to bring up that you think need to be resolved as two groups, please don't forget that. And Pat, please.
Yeah, if I can just clarify a little. We have two groups. We have an IEEE standing committee to manage the IEEE relationship to IETF. So that's what I chair. And then we have an IEEE 802 IETF coordination committee that basically is the leadership of both groups working together to coordinate our work, and Dan and I co-chair that group. So it's a little confusing, but there's actually two groups that we handle that coordination in, one from the IEEE looking out point of view and one from the two groups working together.
Okay. Well, thank you for the clarification. But anyway, if you want to know about the coordination, that's an excellent resource right there. Oh, wait a minute. Well, I'll get back to .12 in a minute. There's a couple of interest groups in 802.15. One's called the Dependability Interest Group, which I think has a lot of, it's related to essentially reliable or quality of service sort of transmission, I believe. High rate rail communications, I don't have information about that. And then there's the terahertz interest group for using terahertz bands, which should be blazingly fast. Other activities we have essentially joint effort with IETF and 6TISH, and in the IEEE, there's an interest group called 6T, which is essentially monitors efforts in the 6TISH working group in IETF and tries to organize, say, appropriate responses. They also will answer questions that may come up. During the last meeting, just a few weeks ago, there was support in this. There was discussion in the 6T group to support 15.12. Actually, what happened was the 15.12 effort has been discussed pretty widely within 802.15 and 802.1 because we wanted to make sure that when the time came for standardization, it would pretty much sail right through. And there's also a hope to broaden the liaison relationship with IETF. There's already a liaison between 802.11 and IETF, and the proposal is to have a liaison between 802.15 and IETF as well. And so hopefully we'll get more about that. And lastly, I want to mention that IEEE Wireless has a relationship with ISO, and there's this process called Partner SDO. And so there's, I don't know how this goes, maybe if you want to say something about it or Pat, but basically we can propose that ISO adopt IEEE standards to be of equal force as other ISO standards. And so we have these three right now, 15.3, high rate wireless multimedia communications. So apparently that's not too controversial. The 15.4 roll-up for 2015 submitted to JTC1, Joint Technical Committee 1 from SC6. So I think they're going to, I guess that means they're looking for a review from that group. And then I mentioned before that body area networking is also submitted. I think Dorothy wants to say something.
Comment is, these are exactly, these are the items that 802.15 is submitting via the ISO IEC JTC1 SC6 process. Underneath it's all underneath this agreement that IEEE and ISO IEC JTC1 have, called this PSDO process, where IEEE is able to submit standards to this group for their consideration for international standardization. And in .11, we've done that for a number of years. The other 802 groups, .15, .16, .3, .1, are also doing that now. So the goal is to get that international standardization approval.
Okay, thank you. Thank you for that. Okay, so for the next couple of minutes, I want to return this .12 proposal because first of all, it is going forward, and second of all, I think it's really relevant to IETF for Internet of Things and 6TISH and so on. So the point was to make 802.15. This is specific to .4. It's not that it couldn't be done for .3 as well, but it's already relatively possibly large scope, so you want to restrict as possible. And again, Wi-Fi is seen as an excellent model for how to support IP networking. So IEEE 802.11 supports a lot of facilities at the higher level protocols, and they don't have to. There's no real reason for 15.4 to require the upper layer protocols to change just because it's .4 instead of .11. So the model is that we would like to create facilities that allow the use of 15.4 and that applications that are using .11 don't have to really be changed. And this should be done while maintaining backward compatibility with existing devices and applications. So if you deploy the .12 code, it doesn't mean that your previous systems are going to be broken. So we want to enable deterministic applications, and you might think like DetNet and so on with with IETF 6-TISH can be used deterministically, and also non-deterministic. The general idea is to create a data link sublayer above the MAC that adapts and configures 802.15.4 MAC for the operation that's desired, and contains existing and soon-to-be released sublayers for 802.15, such as 6LoWPAN key management protocol, which is KMP, as I mentioned before, is basically done. Layer 2 routing, would like to make that available under the 15.12 ULI. Layer 2 routing, however, is not almost done. I don't know how much longer it's going to be, but there's going to be a substantial amount of work, but maybe within a year or something like that. And also we want to definitely fulfill the needs for 6-top. 6-top is the essentially the top interface for using 6-TISH protocols. Here's same content in a picture, and I just wanted to tell you that I didn't have many pictures, so I had to put this in. But you can see that there's a transport layer at the top with what IEEE Wireless would consider to be the upper layer protocols, and then the network layer with IPv6 or v4 with an adapter, and then down this LLC, which you could say that's the upper layer interface with 802.15.12, sits on top of all the MAC layers, which then sit on top of all the PHY layers, and there's quite many of them. Well, I don't know how many, but probably at least a dozen combinations. So another picture shows the MAC and PHY layer below. And that, for instance, above we have V4 and non-IP applications. The LLC work is not exclusive of non-IP work. We want to include also customers that are already using, for instance, other non-IP Internet of Things protocols. So that's pretty much it for the 802.15 part of the presentation. It's very active. There's a lot of people doing good work there. It's open. You're welcome to come after you've been 2 times or 2 plenaries. You can participate as a voting member. There's a lot of emphasis on low power and a wide range of bandwidths, and it is interesting for IETF working groups. We've had a lot of interaction with that. So we also participate in this IEEE IETF coordination group, which has been mentioned before, and looking for a liaison activity. So that's it for the 802.15 part. I have some slides about 802.1 that I want to briefly mention. I got these from JC Zuniga, and he has been active in OmniRAN and privacy efforts in 802.1. So with that, I'll go forward here. So this is the OmniRAN reference model, and I didn't bring in the definition for all these reference points, but basically what you have is, if you looked at WiMAX, the reference point model for WiMAX, you would see similarities in how this has grown up from the WiMAX reference point model. So basically there's an access network with several internal reference points. It's NA is sort of the network access, and then down on the left, the terminal has R1 was always the WiMAX interface, and R8 I don't know if that was a WiMAX or it was added under OmniRAN. Oh, so this OmniRAN, by the way, let me say a word about that. So OmniRAN, well, RAN is radio access network, and OmniRAN means all the radio access networks. So when the group was formed, the idea was that, well, people don't really want to write applications running on the internet that have to care a lot about whether it's .11 or .15 or .16, and which .16 is WiMAX. So the thought was to provide essentially an upper layer interface. And in fact, you may notice that it greatly resembles the goal of 802.15.ULI. But the OmniRAN intention was to enable the similar sort of convenient access to all the 802 wireless groups, or wireless physical MAC layers. I guess I should just say MAC layers. So, well, that didn't really go forward very well, and it's been around now for probably 3 or 4 years, undergoing some revisions in scope, and this is the latest and greatest picture of the architecture. So here, this subscription service you might think of as similar to what handling subscription needs for HLR or HSS, and the coordination and the information service has to do with things like, if, for instance, the TV white space has requires, or they define essentially a database protocol for accessing, so that a terminal can find out what are the available bands for the TV white space. So that's the kind of thing that would be accessible to the access network. And there's obviously other sorts of information service, but the point is, for this one, this is really what's needed to get onto the network. And there's also a protocol on 802.11 called ANQP, and this is sort of a container for querying for features about the network, and that is also considered to be part of this information service. So we have the access network and the terminal and the access router, and then essentially some core or infrastructure requirements. So with that kind of architecture, this shows an example of the kind of use cases, I guess you would say, that they're trying to address to make sure that this reference model allows you to do the network discovery and selection, association between terminal and access network, authentication and authorization, and then several other things. Let's see, what can I say about that? Yeah, then there's the other part where you want to, release the resources when you're tearing down your data path and so on. So this gives you a picture of what OmniRAN they consider to be their use case and their what they're trying to accomplish. A couple of other projects under 802.1. This 802E privacy considerations is also a subject of interest between IEEE and IETF coordination. There's been work done in 802E to try to figure out how to enhance the ability to not allow for trackable MAC addresses, and to identify the threat models and how you can mitigate those threats. So this is currently being worked on under 802.1 in the security task group. And again, if you want information about this, JC Zuniga is an excellent person to contact. He's also co-chair of Interior Working Group, so he'll be here. And lastly, I'll mention, this is what JC wanted me to present for this, but this range assignments for local MAC addresses idea, it's under this, being worked on under 802.1 DCB task group. And DCB is the data center bridging group. And so I think the idea is that there's something about the way that you can do range assignment or pick MAC addresses out of a particular range. I see Pat's going to help me out here. Please.
Yeah, I'm actually chair of the 802.1 data center bridging task group. The addressing assignment were assigned to our group, but they're not necessarily data center. Some of the usage of them is data center, particularly to get addresses for virtual devices and such. But another use is in networks with a lot of things, a lot of small devices, some of which may not even have a global address ever assigned. They may just depend on using a local address. for instance, in an automotive network inside the car where you've got all the sensors and all that, or in a building automation network where you've got a lot of light bulbs that are going in with light bulbs and sensors. We've got LED lights now that can get their power over the Ethernet standard for providing power over the data line.
That's
And
actually a big development, I think, to have the LED lights over.
And so if you start picturing doing that kind of deployment, you're not necessarily going to want to deploy all those with a individual address, a global address assigned to them when it's such an ephemeral object. There's medical equipment, including these pills you swallow, and they don't live very long.
Okay, well, thank you.
So basically, so because I had an interest in that, and I'm sharing that, the data center bridging group, and also there was some commonality, that's where it was assigned, but it's not particularly data center, it's data center and other kind of devices. So, and we've got two projects. One is 802C, which is just to make a local addressing. Right now, the local addressing is half the addressing space. Let's see if this other is this working?
Well, I bet this one's working.
Yeah, so one was we had this flat local address space that's basically just half the address space. There's a bit that one position's local and one position's global, and there was never any structure described for it, or basically very little described even about how you use it. And so we decided that there's a need for having an optional structure to it that somebody can decide to administer the network under, and under that structure use portions of it that are allocated by default to different addressing protocols, and then have other portions that are just for administrators to assign out of. And so that's in 802C, that's just describing the structure of how you use the local address space this way. And then we've got another project, which I don't know if you've got another slide on. It's very recent, so you might not have it there.
Which one is it?
It's 802.1 CQ.
CQ, okay.
Yeah, so it's for a base standard to do an address assignment protocol, actually a kind of a suite of protocols, so that we can allow for both ad hoc kinds of address assignment where you have a network without a server, where you get an address and check whether you've got conflicts, and then or you can have a server-oriented thing where you ask a server for an address. Okay. Yeah.
Well, great. So I think that makes it much clearer why the 802C is relevant to wireless and similar applications. So that's all the slides I have. Please introduce yourself.
Sure. Hi, I'm Jim Fenton. Actually, this is, I think, a question for Dorothy, because it relates to, you were talking about one of the TGs, I hope I've got the terminology right, that was dealing with trying to cut down on the chattiness of some of the protocols and use the channel more efficiently. There's also been some concern about various vendors that are tracking people's behavior through 802.11 beacons that their devices that they're carrying have. Is that an explicit? Is that any sort of a goal of that group? Is it a potential side effect, or is IEEE addressing that at all?
Thank you for your questions. The first question was around the amendment that's looking at probe traffic reduction. So we can talk about the chattiness of protocols, and it's really not, you could say it's a protocol issue, but it's more an implementation issue, and the devices just constantly want to know what access points are out there. So they probe very frequently. And I think I'd want to separate the probe behavior from the location tracking behavior subject. They're really distinct. So the probing mechanisms are, for example, one of the items that 11AI introduces is a requirement on a station to, if it has seen a probe response from an access point directed to a different station, that it not query for the same information. So 11AI introduces additional mechanisms to try and reduce the amount of probe traffic that's out there. And those are typically related to probe requests and responses, not beacon frames. Okay, now so that's the probe reduction. And there are a lot of different techniques you can use to try and reduce that. Now let's step over and talk about MAC address tracking, which is a different subject. There were a couple of articles in the past about various places where they were, the access points were gathering information about particular MAC addresses of clients as they move from place to place, and you could basically map the route that someone took through the city, right, by just seeing where that MAC address goes.
Even when they're not associated?
Even when they're not associated. It's just because you're watching them probe, right, and send that out. Well, we did have discussions about MAC address randomization and putting something for MAC address randomization in the standard. We have not done that to date. What's happened is individual vendors have put in different algorithms for randomizing MAC addresses, like on the client side. So, and here at the IETF, we've had trials, right, MAC address randomization trials, where you can download software on your device and, trigger it, and it'll pick a new MAC address. And so my understanding of the bottom line there is that these devices typically select a random MAC address for their querying, right? And then when they and they might do that on a periodic basis, whether it's every 10 seconds, every minute or whatever, but they'll pick a new MAC address. But then when they actually associate, to keep persistence of the session, they'll keep the same MAC address for that session. So I think there's been a significant amount of negative publicity around that kind of thing, that there's a balance between, you have to find out what, from a client device, you have to find out what access points are out there, right? Otherwise, how will you know? So you're probing and you're asking, okay, are you there? What are your attributes? Versus not wanting anybody to know you're there. I mean, a client device could take a decision to only listen to the responses of others and never to probe, right? The client device doesn't have to probe. So, this addressing the tracking, I think, is something that you don't really need anything in the standard for. Additionally, you need different behaviors implemented on the clients. And to a large extent, that has happened. I also wanted to make one other comment about the .15 request for a liaison. And based on my experience in IETF, the IAB is very reluctant to allocate liaisons to different groups or to assign liaisons to different groups. Currently, there are two IEEE related ones. Eric Gray is the liaison from IETF to 802.1, and Dan Romascanu is the liaison from IETF to IEEE-SA. So my position, for example, as liaison from 802.11 is not recognized at the IAB level. In the IETF, they're very particular about this. So there are liaisons to and liaisons from. So any liaison from IETF is appointed by the IAB, and they'd rather not do it. They'd rather just have the work going on between the working groups or participation in the working groups. And that is really what is happening in .11. My position as from .11 is, from a .11 perspective, I'm expected to come here and represent us or take any questions back. But that's not an official, that's not a IETF IAB recognized position, just to be clear. Okay, so I think we have a queue, Pat, and then Bob.
But let me just make a request. The political discussion about liaison, can we keep it relatively short?
I wasn't going to talk about that at all. So,
okay, great.
We have we also have the privacy project, which is in 802.1, and that's dealing with making recommendations about privacy, producing a privacy guideline. And so that's also a way we're dealing with that. And then I guess if at the time that finishes, if there's a feeling that there are some pieces that need to be standardized to help it along, that would probably be handled as kind of recommendations coming out of that group to do a project. So right now that's all centered in one place because, you know, privacy is and security is something that you need to approach with care to get it right. And so it's in the hands of the experts there.
Yeah, thank you, Pat, for bringing that up. Yes.
Just real quick on the the chair of 802.15, real quick on liaison. What 15 is after is recognizing that we're working now more closely with many groups with an IETF is to create whatever relationship we need to create so that we could share documents in an easy way. Was a big problem in the 6-dish effort. And as we move into 15.12, I'd love to see what we can do to expand that in whatever form it takes, you know, whether, you know, but that's the goal.
Okay.
Thank you, Bob. Stuart? Do you want to say something
can
about
I
that?
just respond to that? So the question, the way we've solved that on the .11 point of view, and I think it was solved at the 802 level with Paul Niklich, is if there's an IETF group that needs access to .11 documents that are not published, the 802.11 chair will make available the username and password to protected, documents to the working group chair in the IETF, and the working group chair will hand that out to people that need it. So we faced that problem. That was our solution. If you're looking for, yeah, okay.
Okay, please, Stuart, go ahead.
You had one slide mentioning the Wi-Fi Alliance,
Yes.
and my understanding is, at least in the early days, the Wi-Fi Alliance certified compliance with the IEEE 802 specs, and devices that passed those tests were allowed to use the Wi-Fi logo, which is a trademarked logo that you can't just use unless you have permission to do it. More recently, the Wi-Fi Alliance has been coming out with things like Wi-Fi Direct, which seems like moving out of the realm of certifying specifications and starting to publish their own. Can you comment on the relationship between IEEE and the Wi-Fi Alliance?
Okay, certainly. So I've also been participating in the Wi-Fi Alliance for, I don't know, neighborhood of 15 years. So Wi-Fi Alliance has always done, so 2 points. One is on the type of testing that they do. They do interoperability certification based on IEEE specs, and they do interoperability certification based on Wi-Fi Alliance developed specs. So the relationship with IEEE is really collaborative and largely non-overlapping. There are areas where the Wi-Fi Alliance has developed their own specs. For example, Wi-Fi Direct, WPS, Wi-Fi Protected Setup. There are a couple of others. And yes, that has happened. in parallel with Wi-Fi Alliance performing interoperability certification based on IEEE 802.11 documents.
Is there any rule of thumb about which specifications tend to come out of IEEE and which tend to come out of Wi-Fi Alliance?
Historically, the MAC and PHY specifications have come out of .11, and documents that address user interfaces or like Wi-Fi protected setup, where it was an addition of really user configuration of the security parameters, came out of Wi-Fi Alliance. Now, that typical rule has been broken in a couple of cases, but that's the general rule of thumb.
Okay, thank you.
Okay.
Yeah, I just wanted, there was something that was said during the tutorial, which a couple of times both people said that all the IEEE 802 documents are publicly available, and that is basically true for all the stuff that goes into the process, all of the presentations, all of the proposals, all that is public. What isn't public, because it's IEEE process rules, is our drafts. Our drafts are kept behind a password. We do have a process with IETF for making drafts available to IETF members when there's things we need to collaborate on, and basically, you know, just get your working group to ask, and we figure it out and we make it available. It's kind of a set process, so it's not a big deal. But that is the one piece of documentation that we can't share without kind of having something. And since IETF doesn't have any password protected area, what we do is we give the working group chair the access credentials, and the working group chair then distributes those out to the people who want access to the documents.
Right, so thank you for the clarification. So for example, if you wanted to read the current layer 2 routing spec, you would have to be able to get into the password protected area from IEEE. That's not publicly available. But if you wanted to see the comments that had been raised against the current spec, all of that is publicly available along with the resolutions for those comments. So it's a very important distinction, and I was overly general when I said that. Thank you.
There is one other piece of data, which is that once our standards are published, we have an agreement with IEEE that all our standards, after 6 months after they're published, are available through a program called Get 802, and can be downloaded for free. So there is a 6-month window wait when you need to buy them if you want access, but after that they're published for free.
Thank you, Pat.
So we are at the end of our time. I'm willing to stay if there's more questions. I don't know, I won't speak for Dorothy, but in a few minutes the IETF reception is starting, I think. And I want to again just mention that I'm very happy to receive email, and if I don't know the answer, I can probably find out somebody that does. So don't hesitate, or I'll be around all week and be happy to talk to anyone about the IEEE 802 wireless. Thank you very much for coming.